separate blue sweets by hand picking them from a mixture of sweets of different colors. We can separate iron particles from sand by using a magnet. How can we separate a salt-sand mixture? Definitely not by hand picking. We can separate common salt from sand by adding water to the salt-sand mixture. Mix the solution thoroughly and carefully with a glass rod. Salt is soluble and sand is not. Insert a funnel inside a conical flask. Place a filter cone in the funnel and slightly wet it with water. Filter the solution of the salt-sand mixture. Since salt is soluble in water, it is passed through the filter paper. Sand particles are trapped in the filter paper as insoluble particles. Transfer the salt solution to a porcelain evaporating dish and heat it using a Bunsen burner. Water in the sodium chloride solution evaporates gradually and leaves the dish with a solid white powder form of sodium chloride. Transfer the wet sand residue to a watch glass. We can remove residual water by blotting with fresh filter papers. Thus, we are able to separate a salt-sand mixture by selecting a suitable solvent and dissolving in it, then following with evaporation. Similarly, an iron-sulfur mixture can be separated by using either the solvent xylene or carbon disulfide. There are some conditions for separation of solids by evaporation. Any one of the components should be soluble. The other component should not be soluble in the chosen solvent. The solvent should be volatile. Solid components should be non-volatile. We know solid becomes liquid on heating. We call this process melting or fusion. Liquid becomes vapor or gas when it is boiled. This is called vaporization. For example, solid ice becomes liquid water on melting. It further becomes water vapor or steam on boiling. Dry ice becomes vapor, skipping the liquid phase. The vapors also become solid powders when cooled. Sublimation is the phenomenon when cooled. Sublimation is the phenomenon whereby a solid changes directly into a vapor on heating. For example, in vapor directly on heating. We have already discussed the fact that sodium chloride and ammonium chloride are soluble in water, so they cannot be separated by the dissolution method. However, sodium chloride and ammonium chloride have different sublimation tendencies. Solid ammonium undergoes sublimation to become its vapor reversibly. Sodium chloride, as we have seen, does not. Let's watch a demonstration of the separation of ammonium chloride from sodium chloride by the sublimation process. The salt mixture is heated on a porcelain pot by keeping a clean, dry funnel inverted. Ammonium chloride sublimes into vapor. Can you see fine white powders deposited near the stem of the inverted funnel? Vapor becomes a fine white powder and deposits on the cooler side of the funnel kept over the pot. Sodium chloride does not sublime and is removed from the porcelain pot. Sublimation is effectively utilized in the printing industry. A dye sublimation printer employs a printing process that uses sublimation of dye on a printing medium. Dye particles coated on the dye ribbon roll are subjected to sublimation by a variable intensity heat source. Vapors of dye are separated from the ribbon and made to fall onto the printing medium to create the image or letter. Different media, such as a plastic card, paper, fabric, or ceramic, can be printed using sublimation printer.